All right, so let's talk about what pH really means. There's the pH scale, right?
The level of acidity.
Yeah, it's what most people would call the level of acidity. It goes from 0 to 14 with 7 in the middle. 7 is what we call neutral. At 7, hydronium equals hydroxide and the pH is 7. Okay? Below pH 7, it's acidic. And the concentration of hydronium is greater than the concentration of hydroxide. Above pH 7 is basic, and the concentration of hydroxide is greater than hydronium. Okay? So below pH 7, it's acidic. Above pH 7, it's basic. Now the key factor here is that this is a log scale. What does it mean to have a log scale? You guys know what that means, have a log scale? Factors of 10. What does that mean, factors of 10? Anybody know what factors of 10 mean? It means that, anybody know anything about earthquakes? They have a scale, right, for how strong an earthquake is. It's called the Richter scale. An earthquake that's a 5 on the Richter scale is 10 times worse than one that's a 4. Okay? It's because it's a log scale. pH is the same way, it's a log scale. So at pH 7, I have 10 times more hydronium than I did at pH 6. The lower down in pH you go, the higher the hydronium. For every 1 unit you go, it goes up by a factor of 10. So if I said you had pH, so if I wanted you to compare pH 1 versus pH 2, you would say there's 10 times more hydronium at pH 1 than there is at pH 2.
That is more acidic at one.
Because it's more acidic at pH 1, hydronium is increasing. Okay? Fair enough? Let's prove that to you. Let's do a little proof. Okay? Remember, pH equals the negative log of the hydronium ion. We all remember that, right? Gave you that today. I can rearrange this. If you go back to algebra class, you can learn how to rearrange it too. It's not worth it. I'll rearrange it for you. The hydronium ion concentration equals 10 to the negative pH. Take my word when I say these two equations are the same. Most of you probably don't know that. So guess what? You know this equation too. Okay? So I've given you 3 equations so far today, right? That you need to know. So let's go back and look at our things. pH equals 1 or pH equals 2. What's the hydronium ion concentration? Well, here, hydronium ion here is equal to 10 to the minus 1. Hydronium ion concentration here is 10 to the minus 2. So this is pH 1, pH 2. If I write this in decimal form, looks like that, doesn't it? This number is 10 times more than this number. Everybody agrees with that? All I do is move the decimal one place. That means it's 10 times more, right? Okay, look at them. pH 2 and pH 1. There's 10 times more hydronium at pH 1 than there is at pH 2. That's because the pH scale is a log scale. All right? Fair enough? Now, there's an example in here that I want you to see that we're going to do. We skipped a bunch of stuff here because we did it all. Come on, where is it? This one. I want you to figure this out. I want you to figure out hydronium and hydroxide for these two. Now look, these two pH values are pretty close together, aren't they? This is 3 and 3.42. So I want you to calculate hydronium and hydroxide for these two. Negative pH. Okay, so that's it. That's hydronium, right?
Oh, I thought we were trying to find this.
Well, that is that. It's the same thing. You don't have to put a decimal form. That's good enough. Right? Now you can't leave this to negative 3.42 because you can't have decimal exponents. But you can do that on your calculator. You don't have to put it all the way out in decimal form, right? So let's do it together. So what's the hydronium for the first one? Or just 10 to the minus third, right?
Yeah.
That's fair enough. So what's hydroxide here? Hydroxide is 10 to the minus 11. You might get that. 1 times 10 to the minus 14 divided by 10 to the minus 3 is 10 to the minus 11. Did y'all get that?
14 minus the 3?
14 minus 3 gives me 11.
Why do you do 14 minus
Because the coefficient, this is just like saying 1 times 10 and 1 times 10. Okay? When the coefficient's 1, all I have to do is worry about these exponents up here. Okay?
2? And how do you use the 1 times 10 to the negative 14?
Yeah, you can. You can still do it that way.
Divided by
1 times 10 to the minus 14 divided by 1 times 10 to the minus 3 will give you 1 times 10 to the minus 11. Okay? Nothing wrong with doing that. Now for this one, it's 10 to the minus 3.42, right? But you can't leave it as a decimal number like this. Okay, not allowed. So who knows how to do that on your calculator? There's a button on your calculator that says 10 to the x. That's the button you want to use. 10 to the negative 3.42. Should be connected to the log button normally. Okay, you gotta do that first. Do that first. There you go. Whoa, no, you did. There you go. Negative 3.42. Yeah, just scroll it and then go to the negative sign. 8 comes into minus 4.
How did you do it?
Hold on a second. Let's see, what calculators y'all have? Who needs to know? Who needs to know how to do it? Okay, let's see your calculator. Who has this calculator here? Or close to it? This is the one I like. This is the bargain basement Walmart one, right? On this one, I'm gonna hit 3.42 negative, and then I do second function 10 to the x. 3.42 negative. And you're good. Okay? Shoes, did you find it? All right, who has a fancy graphing calculator needs to know how to do it. Okay, on this one, you hit second function 10 to the x. It's connected to the log button right there. And then negative 3.42. Okay. Anybody else? We're good on calculator use.
And what, if you, you probably already explained it, but why do you have to change it to 3.8?
Because you can't leave this exponent as a decimal number like that. It's not allowed.
Okay.
The rules say you can't. Okay? So what's the hydroxide concentration for this? Anybody?
It says 3.86. I guess you can round that to 2 times 10 to the negative.
Hold on, what is it? Say it again, Allison.
Oh, I haven't done that yet. Sorry.
Did you get the hydroxide? Times 10 to the negative 9? Huh? 11? Now look at how little difference there is here in these two pH values. And look at how much difference there is in the hydronium ion concentration right here. Okay, you see that? This number right here is about 3 times bigger than that number. And there's only 0.4 difference in the pH unit. That's a tiny difference, isn't it? And students in the other class go, well, what difference does that make? Who cares? And I get it. Who cares about all this stuff? Who cares? Y'all care? No? Not really? You probably would if you got really sick. Does your body have a certain pH? Your blood has a certain pH. Your lymph system has a certain pH. Your urine has a certain pH. What's the pH of your blood? Anybody know?
Supposed to be 7.4.
You would? Between about 7.3 and 7.4. If your blood pH gets down to pH 7, what happens? You're probably extremely sick. That's a condition known as what? Anybody know? Acidosis. Acid, right? It normally means you have a severe bacterial infection. A condition of acid. Not good. Nicht gut. You're more likely going to die if they can't get rid of it. Right? It could be septic, right? That's it. When people go septic, their blood pH goes way down. Why? Because the bacteria grow, and when things grow, they produce acid. All the cells in your body produce acid all the time. When you respire, when all the cells respire. But your blood is buffered to prevent the pH from changing. But when you add more respiration on top of that with a bacterial infection, your blood pH can go down. And that's not good. Okay? The opposite to that, you know what the opposite of acidosis is? Come on, no A&P takers in here? Nobody's taking A&P? It's called alkalosis. If something is alkaline, it means it's basic. Okay? And alkalosis can be caught. Sometimes people with diabetes can have alkalosis. It's a sign that the respiration isn't very efficient. And I don't remember and it has to do with how they're processing organic matter somehow. They're not processing it efficiently, and so things are left very alkaline. It has to do when you break the sugars apart, you leave those OH groups hanging around. And those OHs mean what? Basic, right? For a base, there's lots of OH. For an acid, there's lots of hydronium. Okay? So if you're breaking those OHs off of sugars and not really using the sugar effectively, then that means you probably will be have a condition known as alkalosis. Either one of which is bad for you, okay? Very bad. Most of the processes in your cell work on enzymes and proteins that are dependent upon certain pHs. Proteins change structure depending upon what the pH is. And we're going to talk about that later in the semester when we talk about organic molecules and stuff. So small changes in pH mean big differences in hydronium and hydroxide is the point, okay? You should be able to calculate both of those, all right? We've done several examples that are probably harder than any of the homework you're going to have. Fair enough? I think at this point, you guys, the calculator use should, for you guys, seem like y'all are doing really well with the calculator use. So I think we're doing good, okay? We can go back and do a couple of simple problems real quick.